Now this last thing from section 4.1 involves finding the global maximum and minimums on a closed interval. It sounds really hard, but in this section it's actually the easiest thing to do, so we're just going to talk about this for a second. I'm looking up here where it says local extrema and critical points. It says suppose f is defined on an interval, so I have a function, it has a local maximum, let's say it's a high point at a point that's not an endpoint. So you're at a high point. The next thing they say is if f is differentiable at x equals a. So we have a continuous function, we're at a high point, that's smooth. If we're in a continuous function at a high point, that's smooth, the derivative is 0. Right? Technically that's a theorem, but the minute you actually try to draw anything like that, you can tell the derivative is going to be 0, and so we're just going to move on past that. People don't apply that theorem. This is the way it gets applied. If we happen to have a continuous function on a closed interval, now that happens very often in physical applications because things don't actually go on forever. It says the only places where you have to look to find a global maximum or minimum have to be either at a place where the derivative is 0, or at a place where the derivative is undefined, or at an endpoint. Now what that does is gives us the following procedure. It says, look, if we want to find the global maximums of a continuous function and we have a closed interval, just find all the critical points. The second thing you want to do is make sure you're going to make a table, because once we have the critical points and the endpoints, this little test up here says that the high point and the low point both have to be included in that set. So we just have to make a table of function values, and then the lowest value in the table is the global minimum, the greatest value in the table is the global maximum. Let's just look at a absolutely typical application of this. Let's do this. Here we go. It says find the global extrema. They gave us a function, f of x equals x squared plus 2 over x. Now if they didn't give us a closed interval, we have to go through the entire graphing procedure to find out what the global high points and the global low points are. But if they give us a closed interval, and I'm going to try and do this every time, I'm going to get a little smiley face because it's a lot less work. What we need to do is find the critical points first. So what we're going to do is we're going to take the derivative. It's just 2x minus 2 over x squared. I like to write that like a fraction because we need to find all the places where the derivative is 0 and all the places where the derivative is undefined. So I get a common denominator and I'm going to factor just a little tiny bit. I get 2 times x cubed minus 1 all over x squared, like that. Now this is undefined when x equals 0. This is equal to 0 when the top is equal to 0, and that's when x equals 1. Now, when they say find the global maximums, what are we supposed to do? We're supposed to find the critical points, find the endpoints, but they give us, and just make a table of values. So all we have to do to finish this problem is to make a table and draw a conclusion. So I'm going to go over to x like this. So I'm going to start making a table. Now these are function values, because we are guaranteed that the high point and the low point is in the set. We just have to find out which is the highest and which is the lowest. So for example, you'd think I'd put in 0, but 0 isn't in our interval, so we don't have to worry about that. So 1/2 has to go there, and 1 has to go there, and 2 has to go there, like that. And we just need to plug them in. And when I plug in a half, this is 4, this is going to be 4 1/4. When I plug in 1, I get 3. Is that right? I think that's true. When I plug in 2, I think we get 5, right? So this is the local min. I'm sorry, this is the global min. Because they're telling us our entire universe is just from 1/2 to 2. And this is the global max. That's usually enough to write down. Usually we have to try to find, sometimes they'll ask for the extreme values. Well, okay, the extreme low value is 3, the extreme high value is 5. Sometimes they're going to ask for the maximum point. Well, the maximum point would be 2, 5. The minimum point would be 1, 3, etc. So how we finish the question just depends on how they asked. But asking this way is all we had to do. It's very straightforward. If we have a function on a closed interval and they ask for global extrema, I make a smiley face because it's less work to do than every other calculus problem we do in this chapter.